Today we are going to create these volumetric smoke portals inside Blender 3.6 with its latest addition, simulation nodes. I start by adding a mesh plane and renaming it to Portal Circle. I am going to create this portal in two layers. Portal Circle, which will be in front, and then the portal tube. Let's add a new geometry node setup for the Portal Circle. We don't need the group input. Our first step is to create the portal shape. I am thinking of a donut or a torus shape. So add a curved circle node followed by a curve to mesh node. And I duplicate this circle and plug it into the profile curve socket. I turn down the radius to around 0.08. Now add a transform geometry node and rotate this 90 degrees on the x-axis. The portal shape is ready. Now I distribute some points on this surface. Use distribute points on faces node. Turn up this density to get more points. Since we need a lot of points, I plug a multiply map node to density and set the first value to something like 100. This way I can easily add more points to the surface if needed. For the tutorial, I set the density to 100. Now let's add some movement to these points. First, I want them to go outwards from the center. To offset or displace anything inside geometry nodes, we use set position node. I add a position node and plug it to offset. You can see our points went outwards a bit. But I want to do this step every single frame. I want to add the position of the points back to their position in every frame. In other words, I want to run this on a loop. And that's where the simulation nodes come in handy. I'm going to delete this for now, but I will add it later again. Everything we put inside this zone will run on a loop. So, like before, I add a set position node and plug the position to offset. But now when I hit play, it immediately went away from the center. I add a vector math scale node to reduce the strength of the position we are adding. I set this to 0.04. Honestly, we can do this step without the simulation nodes, but simulation nodes gives us the opportunity to go further with this, especially when we want to emit more particles or more points that didn't exist on the first frame. So for that, I add a join geometry node and plug our points like this. Now, since this join geometry node is inside the simulation zone, we are adding these points again every single frame. Hit play and you can see we are getting more and more points every frame. Right now they are all following the same line. That's because all of these points have the exact same distribution. To change it, I plug a scene time frame into the seed socket. This will change the distribution pattern every frame. And by doing so, it changes the spawning position of the points we are feeding into the simulation. Now it has more randomness. But you may already realize that we are adding hundreds of new points to the scene every frame. This could easily go out of hand at some point. And also, I don't need them to last that long, so I need to delete them after some time. For that, I need a way to calculate the particle's age, and when they reach their maximum age, I can kill them off. Select one of our simulation nodes and in the Properties tab under Simulation States, I add a new integer attribute and call it age. This adds an integer input and output to each simulation node. Age starts at 0 and for every frame I add 1 to the age. Then capture that value using capture attribute node. We need to capture this to make it work with the geometry. Otherwise, it will be just a value that gives us the frame number. Now plug that into the simulation output's age socket. This way, that age number will pass to here and use that in the next frame. We can use this output to read the age at any time. When I view it, you can see it gives me the age of each point. Now let's delete some points that reach their peak age. Add delete geometry node. Drag from the edge and search for compare greater than or equal node. Set the B value to 15 and plug the result into this selection socket. Now every point that reaches the age of 15 will get deleted. Let's randomize this age number using a random value node. I set the minimum to 12 and the maximum to 20. This way, some particle will last for 20 frames while some last just 12. Let's organize these before moving forward. I call these kill particles. And this is our portal size. And here we distributed some points. Now let's modify our points movements. I want them to go back a little. Add a vector math add node after the previous outwards movement. I add an offset on the y-axis. Let's improve this a bit. Drag from here and add a combine XYZ node and expose the y-axis. Plug a multiply node into it and plug its first value into this delta time of the simulation. Delta time gives us the time passed since the last frame, and it is frame rate independent. This helps to keep the speed consistent with the playback. Tweak the multiply strength to find a suitable value. You can do this step to all of our movements if you want to. Let's add some noise to the movement. I duplicate the add node and put it here. Add a noise texture. By default, noise texture only gives us positive values. So plug a map range node and set the two mean values to -1. This will remap the values to go from -1 to 1 in all directions. Add a scale node to control the strength of the noise and plug that to add node. That's too much noise, so reduce it to 0.1. Now I play with the noise texture properties to get something I like. Adjust each movement's strength as well. So our basic movements has some noise to it, but it is the same in every frame. To randomize that, I set the texture to 4D, which gives us this W socket to change the noise pattern. I plug a same time node with a multiply node to change the W value with time. Change this multiply value to change the speed. So points movements are done. Let's organize these a bit more. And this is it. This is basically our portal circle. All left to do is convert these points to volume. For that, drop a points to volume node here. Reduce the radius to something like 0.1, density to 3, and increase the voxel amount. We can change these settings later. Actually, let's make this radius change with time. For that, I use the age value and plug it into a map range node. Plug the maximum age value into the from max socket. Now for this to min, we can set our starting radius, and here for to max, we can set the dying radius. Plug that into the radius. Now it decreases its point volume radius with age. Let's work on the material. Add a set material node. Create a new material and assign it. I make a new window here and change it to shader editor. Let's go to Eevee. Enable the volumetric shadows. Now in the material, we don't need the principal VSDF. Delete that and add principal volume node and plug it into volume socket. We can see our volume shape here, but we are also seeing this big volume cube. To get rid of that, I add a volume info node and plug the density into this density value. You can adjust the density value from here in the geo setup. Now remove this attribute, and that cube is gone. I brighten up the volume color and also add a point light in the middle. Increase its strength. Enable shadows and make this blue. Now in the volumetric settings in Eevee, you can decrease the tile size to increase the volume quality. But before that, let's add a camera. Frame it like this. I set it to 35mm lens. In render settings, these start and end values define where in our scene volumes start and end. Right now in this scene, we don't have a volume that goes for 100 meters. That means we can reduce this range to get a better quality in the area we want. Let's use this measuring tool to measure the distance to the start and end of the portal from the camera. Once we add the second layer of the portal, we will have a volume going for somewhere around here, and it will start around here at 5.7 meter. So let's put those numbers in the settings. I set the start to 5.7 and the end to 15. This will make the volume visible only in this range from our viewing point. When you move around in the viewport and go out of that range, it disappears, but you can always use the camera to zoom in or zoom out. Now, if you want a further increase in quality, you can increase the voxel amount and decrease this tile size to get even better volumetric results in the render. Let's improve the volume material with a noise texture. I add a multiply node here. Then add a noise texture. Plug texture coordinates to it. Plug the texture into the multiply node. Add a color ramp and increase the contrast to better see the noise texture. Play with the noise settings to get a good noise pattern. You can change the coordinates to something like object, camera, or window to get different results. Once you find a decent noise scale, change the slider to smooth it out. Just like before, I like to change the noise pattern with time. So change this to 4D. Since we don't have a scene time node in the shade editor, I type #frame to get the current frame number of the animation and divide it by something like 100. Now it will animate with time. Let's increase the light intensity and set a custom distance as well. I also increased the starting radius to 0.2. Now let's focus on the second layer. You can create the second part of the portal inside this same setup, but to keep things clear and easy to understand, I prefer doing it separately. So duplicate the portal object. I call this portal tube. And make sure you duplicate the geo setup as well. Otherwise, you're going to overwrite it. Let's call this one also portal tube. Now, before we move on to the tube, what you can do is you can bake the previous simulation. Select the portal circle, and in the physics tab, you will see this new option in Blender 3.6 called simulation nodes. This is where we bake the sim. Hit bake and it will create a bake data folder next to your blend file. Once that's done, let's hide the portal circle. Select the tube and make sure you are in the portal tube geo setup. Trust me, if you're using this spinning option, you could really mix this up. I mean, not that it happened to me, or this is definitely not the second time I am recording this. I'm just saying you could mix this up. To see things clearly, I am going to view just our points. I reduce the outward noise movement. I want these points to slowly attract towards one point in the back. For that, I add an empty and place it 2-3 units behind. Now drag that empty object into the setup. Set it to relative. To get the direction from each point to empty, we can subtract their position from empty's location. Then I add a normalized node. This will set the scale of that vector to 1. Then add a scale node to control the strength. Let's plug this to offset to see only this movement in action. It is going the opposite way. Just switch these two. Now it is going towards the empty. Actually, they are dying before reaching the empty. You can either increase the maximum edge or just bring the empty closer. Now I replace this directional movement with this new setup. Let's add a second layer of noise. I duplicate this whole setup and connect it like this. Here I increase the scale of the noise texture. Adjust their strength a little bit as well. I also increase the point density to 500. Increase the maximum edge a bit as well. Now let's view this with the volume. I position the camera on the other side. So let me rotate this 180. And now we have our portal tube. I also changed the start radius to 0.15. Let's unhide the portal circle. I duplicate the point light and put it at the end of the portal. Change its color as well. To animate the portal opening, I animate the radius of our main circle. But before that, you have to delete the previous bake. Then set keyframes to make it go from 0 to 1. Do it for both portal circle and tube, and then you can bake the simulation. If you want to see this in real time before rendering it, in the Output tab, set a path. Set the file format to FFmpeg and codec to MPEG-4. Quality to high quality. Also, let's halve the resolution. Now go to View, Viewport Render Animation. This will render out your viewport. To view the rendered animation, go to Render View Animation. And that's it. That's our volumetric portal effect with simulation nodes inside Blender 3.6. For my next tutorial, I am trying to render these bugs, but they just keep running away from the lights. So if you are subscribed to the channel, you will get notified once I catch them. You know what? To improve the simulation, you can increase the point density and reduce the volume point radius. You can use the same points to instance something like icospheres to create these small bits in the sim. To have a better performance in the viewport, use isViewport node with a switch node to set a small value for the viewport and a higher value for the render. You can also use the switch node and animate the switch to stop feeding more points into simulation. This way, simulation will be over once the final point gets deleted. So that's it. I hope you learned something cool, something new. That's what we like to do. We not only create stuff, we let you create with us. Hit the like button, comment your thoughts below, and don't forget to subscribe to HellFX Learn so you won't miss out when the next video drops. Until next time,